Good morning, students. Today we will start with the revision class, that is chapter ray optics. Right. So from this chapter, we have weightage of marks is 9 marks. So from this 9 marks, one question will come for 1 marks, and one question for 5 marks, and one question for 3 marks. Right. So this 5 marks question, either it may come from numerical or it may come from theory. Right. So compulsory one question will come from either numerical or from theory. So one question for 1 marks. Either they may ask one question for 1 marks, or they may ask one question in 2 marks. Right. So this is about the weightage of the marks. That is about total 9 marks. To solve the numerical problem, so first we need to understand the theory. So without knowing the theory, we can't solve the numerical problems. Right? So first start with the overview of the chapter. Right? So this chapter starts with topic reflection. Right? So from this topic reflection, we need to study laws of reflection. So we have 2 laws of reflection, right? So then next, sign convention, right? So this will not ask for any exam, but this is helpful for deriving the relation, and it helps for solving the problems, right? So next is mirror equation and magnification. So this is important derivation for 5 marks, or they may ask the problems on this mirror equation, right? So the last is image formation, right? So image formation, they may ask for 2 marks, or they ask for 1 mark, right? So image formation in mirrors, right? So these are the important concepts which we have to study in the topic reflection, right? So next we topic is refraction, right? So in the refraction we need to study laws of refraction. So here also we have 2 laws of refraction. So in that, the main one is Snell's law. So Snell's law helps in the further derivation. So by using the Snell's law, we are going to derive the lens formula and lens makers formula and refraction through the spherical surfaces, right? So here also we have 2 laws. So next is total internal reflection. So this is important for 3 marks. So they ask for the definition of the total internal reflection and the conditions for total internal reflections, or they may ask for the applications of the total internal reflection and what is critical angle and how it relates with the refractive index, right? So this one is the important for 3 marks, right? So next, some natural phenomena of the refraction, that is total internal reflection. That means applications of the total internal reflections, right? So that is for 3 marks, possibility of asking question, right? So next, relation between, that is derive the relation, that is refraction through spherical surface, that is relation between U, V, R and N, that is refractive index. So this one is also important. So this is for 5 marks, right? So this one is the important derivation. So in the topic refraction. Next one is lens makers formula. This is also important for 5 marks. Next, within this lens makers formula, we have one more, that is lens formula. Lens formula, magnification of the lens formula. Either they may ask for the lens makers formula or lens formula. That is for the 5 marks. So next, two thin lenses in contact. So in the previous years they asked this derivation for 5 marks. So nowadays they started to ask this derivation for 3 marks. But also this derivation is important for 3 marks or 5 marks. So in this next one is power of the lens. Power of a lens or power of the lens. So this is important for 2 marks or 1 mark. So several times they ask for 1 marks on this topic, that is what is power of lens or how power of lens relates with the focal length of the lens, that is P is inversely proportional to 1 by f, that is f. They ask for that relation, right? Next, after the power of lens, we have here two thin lenses in contact. So this is the topic about the reflection and refraction. So along with this we have optical instruments. So it includes one more derivation here, that is prism formula. So here this one is important derivation, prism formula, that is refractive index n is equals to sine of a plus d by 2 whole divided by sine of a by 2. So this year, that is 2020, they asked one problem on this topic, that is prism formula, and this year they asked here one more topic here, that one is the relation between R and F. So this year they asked this question for 3 marks. That is in the topic reflection, right? So prism formula they asked 5 marks numerical problem, right? So in the last year, that is in 2019, they asked the relation between U, V, R and N, and again they asked the lens maker formula for 5 marks derivation, right? So these are the topics on reflection and refraction. So in optical instrument, so they ask the mathematical form for microscope and telescope. That is, they may ask for ray diagram or mathematical expression for simple microscope or for the telescope. So here they ask for 2 marks, ray diagram of the microscope, or they ask for the telescope. That is, they may ask the ray diagram of simple microscope or compound microscope, or they may ask the expression for the telescope, magnification power of the telescope, right? So this is the overview of the chapter. So all these topics are very important. So whichever topic we left there, so those are may ask for 1 mark. That is applications of reflection, refraction, and the optical instruments we have studied. That one is the mathematical formula. They ask for 1 marks, right? So these are the important. So here for 1 marks they asked for the image formation. Right, so here for 1 marks. So out of all these topics, we are getting 9 marks from this topic. So if you observe here, we have one derivation. Here we have 1, that is 2, 3, 4, and here we have 5. Right? So we need to practice all these 5 derivations. So that is for 5 marks, and again one more derivation here for 3 marks. Right? So these are the few important derivations. Out of these derivation, any one derivation will appear in the main examination, because this year they asked the numerical problem. So the possibility of asking the derivation in this chapter is very crucial, right? So we need to practice all these derivations. So if we practice these derivations, then we can easily solve the numerical problems also, right? So next, move on to the topic starts with reflection, right? So as already you studied in the class 10th only, so reflection. So what is reflection? When a ray of light which incident on the surface which separates the two mediums, that is, this one is the surface, it separates the two medium 1, and here we have medium 2, right? So some part of the light will send back to the same medium, so that phenomenon we call as reflection, and some part is transmitted, so that part we call as the refraction, and some part is absorbed by the surface or the medium, so that one we call as absorption, right? So what is reflection? When a ray of light or a beam of light which incidents on the surface which separates the two medium, then some part of the light or beam which is sent back to the same medium, so that phenomenon we call as reflection. So now at the where the point which incident light falls onto the surface, so that point we call as point of incidence, right? So next, laws of reflection. The ray which incident on the surface, so that ray is called as incident ray. The ray which sends back to the same medium, then that one we call as reflected ray, right? So we have two laws of reflection. So at the point of incidence, the incident ray, the reflected ray, and the normal which is drawn perpendicular to the surface. So this one is the normal, right? So at the point of incidence, the incident ray, the normal, and the reflected ray all are lying in a same plane. So that one is the first law of reflection, right? So second law of reflection is the angle which made the incident ray which made an angle with the normal, so that angle we call as angle of incidence, and the reflected ray which makes an angle with the normal, then that angle we call as angle of reflection. So second law says that the angle of incidence is equals to angle of reflection. So that one is the second law, that is I is equals to R, right? If I is equals to 30 degree, then R is also equals to 30 degree. So these are the two laws of reflection. So first law, the incident ray, the normal, and the reflected ray all are lying in a same plane, and second law is the angle of incidence is equals to the angle of reflection, right? So what is angle of incidence means? The incident ray which makes an angle with the normal, then that angle we call as angle of incidence. Then the ray, the reflected ray which makes an angle with the normal, so that angle we call as angle of reflection, right? So these are the two laws of reflection. So next, sign convention. So we are following the Cartesian sign convention. We have the spherical mirrors, right? This one is the principal axis, and this point, the midpoint of the mirror, we call as pole, and where F is the focus. If any ray which is parallel to the principal axis which falls onto this surface after reflection, they all meet at a point, so that point we call as the focus, right? Next, center of curvature. So center of curvature is denoted by C. So this one is the center of the sphere out of which this mirror is a part, right? So the distance between pole and to the top of the focus we call as the focal length. That one is denoted by F, right? So the distance which is measured from center of curvature to the pole, so that distance we call as radius of curvature. So that is denoted by R, right? So next, in the sign convention, we have three sign conventions. So the first one is all the distances are measured from the pole, right? So if we have placing one object here, so if we consider this one is the object A, B. So this object AB is measured from the pole only, from this direction, from here to here we are going to measure the distance. So if we get the image here, then we need to measure the distance from pole only. So that one is the first sign convention, that is all the distances which are measured from pole only. So here we have the focus. If we need to measure the focus, that is, we need to measure from pole itself. From here to here, we are going to measuring the distance. That is from pole to F or pole to C or pole to the object. Right? So this one is the first point. That is all the distances which are measured from pole only. Right? So next, second one is the heights which are measured above the principal axis are taken to be positive. The heights which are measuring above the principal axis, so that one we are going to take as positive. So next, the heights which are going to measure below the principal axis, so that one should be taken as negative, right? If we consider this one as the image, right? So second point is the heights which are going to measure above the principal axis, so that must be taken as positive, and the heights which are going to measure below the principal axis, so that one should be taken as negative, right? So next, and the third one is if this one is the direction of the incident ray, so if you measure the distance in the direction of incident ray is taken as positive, right? So if you measure the distance in the direction of the incident ray should be taken as positive, and if you measure the distance which is opposite to the direction of incident ray, so that one should be taken as negative. So this should be negative and here should be positive, right? So if we measure the distance in the direction of the incident ray, then that should be taken as positive. Then if we measure the distance which is opposite to the direction of the incident ray, then those values should be taken as negative, right? So for example, the if object is here, then the rays which are emanating from this object towards from left to right. Now if we want to measure this object distance, then we need to measure this distance from pole only, from this direction, right? From right to left, but the direction of incident ray is from left to right, then the object distance is negative. So we are taken object distance as negative because the direction of incident ray is from left to right, but from the first rule we need to measure the distance from pole, that is from right to left, right? So from here to here we are going to measure the distance, but the ray of incident ray which is from left to right, so for that reason the object distance should be negative, right? So in the similar manner, if you are going to measure the focus, that is focal length, that should be also negative. That radius of curvature is also negative because these are opposite to the direction of the incident ray, right? So this is helpful in the derivation and by solving the problems, right? So this is about the sign convention. So here we have three sign conventions. So the first one is all the distances are measured from pole. That one is the first point, and the second point is the distances or heights which are measuring above the principal axis should be positive, and the heights which are measuring below the principal axis, that should be negative, right? So the last one is the distances which are measuring in the direction of the incident ray taken as positive, and the distances which are measuring opposite to the direction of incident ray, that one should be taken as negative, right? So these are the three Cartesian sign convention. So this helps in mirrors and also in lenses. We follow the same three rules, right? So this is about the sign convention, right? So next, so next, relation between R and F. So where R is the radius of curvature and F is the focal length, right? So for that we are considering one mirror, right? So this one is the principal axis. So here we have pole, focus, center of curvature, right? So considering the object is at some distance behind the sea, the rays which are emanating from the object is parallel to the principal axis, right? Like this. So this becomes the incident ray, right? So any rays which are parallel to the principal axis, so after reflection, all the rays should be converged at a point. That point we call as the focus, right? So this becomes the reflected ray. That means the reflected ray is passing through the focus, right? So as we starting discuss, that is loss of reflection. Here is the surface. So this is the plane surface, right? So when a ray which falls onto the surface, then it sends back to the same medium. If we draw the normal at the point of incidence, that means which is perpendicular to the surface, so that one is the normal, right? So here also we need to draw the normal, but this surface is not the plane surface, right? So if we want to draw the normal for this curved surface, first at the point of incidence we need to draw one tangent, right? So at the point of incidence we need to draw one tangent to this curved surface, that is for the mirror. Next we need to draw perpendicular to that of the tangent, that is if we draw one line, so that line should be perpendicular to the tangent, right? So this line gives the normal, right? So always if we draw any normal at the curved surface, so that normal is always passing through the center of curvature, so that gives the radius of the curvature of the mirror, right? like this. So this becomes, if you take this one as m, then Cm is the normal. Then if we apply the laws of reflection, the incident ray which makes an angle with the normal, then that angle we call as angle of incidence, right? So this one is the reflected ray. So this ray makes an angle with this normal, so that angle we call as angle of reflection, right? So from laws of reflection, angle I is equals to angle R. So for that we take one common angle, that one is angle theta. So here is also angle theta, right? So from the laws of reflection, angle of incidence is equals to angle of reflection. So for that reason, angle theta is equals to angle theta here, right? So now draw the perpendicular from point M to the principal axis. Next, we need to draw the perpendicular from point M to this principal axis. So calling that point as point N, right? So if we observe here, the angle MCP or MCN, that is angle MCP, that is equals to, so MCP. So here is angle theta, then opposite angle should be, here should be angle theta, right? So because it is in the form of Z shape, so here we have theta means in the opposite angle should be also theta, right? So angle MCP is equals to angle theta, right? So in the similar case, if we draw the angle plotting MFP, P, that is equals to, so if you observe here, so this becomes the Z shape, then total angle M is how much? Theta plus theta, that is equals to 2 theta. Then here angle M is also equals to how much? That is equals to 2 theta, right? So the total angle M is how much? Theta plus theta. So for that reason angle F becomes 2 theta. So MFP is equals to how much? That is 2 theta. Right? Now considering the triangles MCN and MFN. Right? So from triangle MCN, we can write tan theta is equals to, so tan theta is equals to opposite side by adjacent side, that is mn divided by cn, right? So we can write like this mcn. So angle theta is here, tan theta is equals to opposite side mn divided by adjacent side, that is cn, right? Tan theta is equals to mn by cn. So similarly from triangle, one more triangle mfn. So from triangle MFN we can write, so the angle is how much? That is tan 2 theta, that is equals to opposite side is what? Mn divided by Fn, right? For small angles, because so this distance is very large compared to the surface of the mirror, so this angle should be very long, so that becomes m, point N and point P are very close to each other, right? So for small angles, that means here we have tan theta and 2 theta. So for small angles, tan theta is approximately equals to theta and tan 2 theta is approximately equals to 2 theta. Right? So now we can write this tan theta as theta is equals to mn by cn, and we can write tan 2 theta can be written as 2 theta is equals to mn by f n, right? So now observe, so here we have the value of theta. Now we can substitute here, that is 2 into the value of theta is what? Mn divided by Cn, that is equals to Mn divided by Fn. Right? So in the LHS and RHS we have the common term. So which term it is? Mn, and here we have Mn. So those two terms are get cancelled. Right? So the remaining is Fn. That is Fn, that is equals to Cn divided by 2. Right? So as already said, for small angles, the point N is almost nearer to point P. That means these 2 points considering as the same point, right? So then this distance, if you measure the distance from pole to the focus, so that distance we take as F. That one is the focal length. Similarly, if you measure the distance from center of curvature to the focus, so that distance we are going to take as R. Right? So for small angles, so I will write here point P is nearer to N. So we can write Fn is equals to Fp and Cn is equals to Cp, right? So for small angles we are writing the two conditions. So one condition is tan theta is approximately equals to theta, tan 2 theta is approximately equals to 2 theta, and as this angle is very small, so this distance is very small, negligible amount. So hence point N is approximately equals to point P. So for that reason Fn is almost equal to Fp. So that one we can written Fn is equals to Fp, Cn is equals to Cp. And if we know the value, that is Fp, that is what it is, Fp is F, focal length, that one is the F. So here Cp is radius of curvature, that is R, right? So now we substitute here, that is Fn is what? F, that is Cn is what? R, that divided by 2. So this gives the relation of F and R, that is focal length and radius of curvature. So this year only they asked this question for 3 marks. So for 1 mark they can directly ask what is the relation between F and R, that is focal length is always half of the radius of curvature. So if you observe here, this distance is half to that of the focus, right? So this is the derivation. So simple derivation, just we need to mention all this properly, right? So next the important is this point, that is considering for small angles we write these two conditions, tan theta, tan 2 theta, and the point P is nearer to point N, then we can write these two. Then we substitute, then we get the equation F is equals to R by 2. Right? So this one is for 3 marks. They ask this one for 1 mark also, only for this relation. Right? Where F is the focal length and R is the radius of curvature. Right? Next. So next relation is mirror formula. So from this they may ask for problem, that is numerical problem, or they ask for the derivation. So for that we need to know the derivation to solving the problem, right? So here also considering a mirror, right? So this is the principal axis, and here is the pole P, focus F, center of curvature C, right? Considering an object A, B, right? So to construct an image, we need minimum two rays to draw or plot the image, right? So this one is the object. From this object, the rays are emanating. That is number of rays which are emanating. That means the number of rays which are coming out from this object. So considering only minimum two, we can plot the image. So here we are going to consider the three rays. So the first ray is the ray which is parallel to that of the principal axis. So the first ray is the ray which is coming out from the object AB. This one will be written as object, right? So the first ray is which is parallel to the principal axis. So as already said, any ray which is passing parallel to the principal axis, then after reflection, the ray will comes out from the focus, right? So the ray, any ray which is passing parallel to the principal axis, then after reflection, the reflected rays always comes through the point. That one is the focus point, right? So next, considering the second ray which falls to the pole of the mirror, then after reflection, so if we consider this one is the angle of incidence, so here this principal axis acts as the normal. So after reflection, it makes the angle same angle. So if you plot angle here, so angle I is equals to angle R. So at which angle the ray will falls onto the pole, the same angle it will reflect from the pole, right? So this one is the second ray, right? And the last ray we are going to consider is which is passing through the curvature. right? So this one is the third ray which is passing through the center of curvature. So any ray which passing through the center of curvature, then it falls onto the mirror, then it reflects back to the same. So this incidence we call as normal incidence. So any ray which is passing through the center of curvature, then the reflected ray will follow the same path, that is it retraces the same path. So if you observe here, so this one is the reflected ray, so here we have the reflected ray, so these three reflected ray meeting at a point, so this point gives the image of the object, right? So if you observe here, the points which are emanating from A after reflection, all the reflected rays are meeting at a one point, so this point gives the image of the object, right? So this one we call as A dash, and here we call this one as the B dash, right? So AB is the object and A dash B dash is the image of the object AB, right? So here we consider the three rays. One is passing parallel to the principal axis, and second one is falls onto the pole, and third one is which passing through the center of curvature. So after reflection, all the three rays are converged at a point. So the convergent point we use the image of the object, that is the AB, right? So naming this point as M, right? So now, so from F to P, this distance we call as the focal length F. Next, from image to the pole, that can be taken as V, where V is the image distance. So naming the image distance as V, right? So next, from center of curvature to the pole, that gives the radius of curvature R, and the last one is object distance, that is also measured from pole, so object distance we taken as U, right? After obtaining the image, where F is the focal length, V is the image distance, R is the radius of curvature, and U is the object distance, right? So now, from the triangle, so if you observe here, B dash A dash is the image. So from triangles, one is B dash A dash F. So from triangle B dash A dash F, and the triangle F M P. F, M and P. So as the object is farther away from the curved mirror, so this curved surface is observed like a almost straight line, that is MP is almost a straight line to that of the AB, because AB is parallel that to the MP, right? So here we have the two triangles, so I will plot here. Considering these two triangles, so here we have B dash, A dash, F, and here it is M and P. So here we have two triangles. Considering these two triangles, B dash, A dash, F, and F, M, P. So these two triangles are similar triangles. So from that we can write B dash A dash divided by, so this ratio B dash A dash divided by MP, that is equals to B dash F divided by FP, right? So from these two triangles, so these two are similar triangles, so we can equate the ratios of the sides of the two triangles, that is b dash a dash by mp is equals to b dash f divided by fp, as ab is equals to mp, right? So we can write b dash a dash divided by ba is equals to b dash f divided by fp. So because ab is equals to mp, right? So from these two triangles we get the equation. So this equation is equation 1, right? So next, in the similar way, we considering the triangles from triangle b dash a dash p, b dash a dash p, and triangle a b p, right? So those two triangles are like this, right? So here a b, here b dash a dash, and this point is p. So considering these two triangles a p b and a dash b dash p, so as laws of reflection, here the angle of incidence is equals to angle of reflection, then the angle APB is equals to angle B dash P A dash, and also these two are angles. Angle ABP is 90 degree and angle A dash B dash P is 90 degree. Then we can say these two triangles are similar triangles. So from these two we can equating, that one is the fractional ratios. If we write the ratios of the two sides, so this one and this one, that one is B dash A dash by BA, that is equals to next B dash P and BP, right? So B dash P divided by BP, calling this equation as equation 2, right? So if you observe these two equations, equation 1 and equation 2, in the LHS we have the same terms, so we can equating the RHS, right? So from equation 1 and 2, so here in the LHS we have the common terms, so we can equate the RHS terms, right? So that one is B dash F divided by Fp, that is equals to B dash P divided by Bp, right? So this one is the third equation, right? Next, so B dash F, so this distance can written as, so I will write here, so B dash F can be written as B dash P minus Fp, right? So we can write this distance B dash F in terms of B dash P minus Fp. So if we equate here B dash P minus Fp whole divided by Fp, that is equals to B dash P divided by Bp, right? So now by using sign convention, right? So by using the sign convention, so B dash P, that means here to here B dash P, we taken that one as the image distance, that one is V. So as the incident ray is from left to right, so we are measuring the distance from pole, that is opposite, right? So B dash P can taken as B dash P is equals to minus V, right? So from sign convention, B dash P we taken as minus V. So next is Fp. So Fp is what? Focal length. So this is also opposite to the direction of the incident ray. So hence Fp is also be taken as minus F. So next Bp. The third one is Bp, right? So where Bp is the object distance, that one we taken as U, which is also opposite to the direction of the incident, right? So BP is also minus U, right? So now equate all these sign conventions to the equation 3, right? So if we substitute all these equations in equations 3, we get b dash p is what? Minus b minus of minus f whole divided by minus f. That one is equals to b dash p is minus b divided by bp is minus u, right? So here we can take minus as common. So here also minus, in the denominator also minus. So we can cancel. So we get v minus f divided by f, that is equals to, in the numerator denominator we have minus, then we can cancel, we get v by u, right? Now if we simplify, cross multiplying, vu minus uf, that is equals to fv, right? So if we write that equation, vu minus uf, that is equals to fv. Now divide this whole equation by fuv, right? So this whole equation we are going to divide by fuv, right? So here vu get cancelled, so we get 1 by f minus uf, we get 1 by v, that is equals to, here fv we get 1 by u, right? So now we get 1 by f is equals to 1 by v plus 1 by u. So this one is the mirror equation, right? So this one is the final solution, right? So 1 by f is equals to 1 by v plus 1 by u, right? So this derivation is for 5 marks. So this will help for solving the problems also, right? So next, magnification, linear magnification. So magnification is the ratio of the height of the image to that of the height of the object. So that ratio we call as the magnification. So magnification is denoted by m, that is equals to the ratio of the height of the image to the height of the object, right? Magnification m is equals to height of the image, that is b dash a dash divided by a b, right? So that one we call as the magnification. Now we need to find the magnification in terms of the image distance unto that of the object distance. So by using this relation, right? So b dash f by fp is equals to b dash p by bp. Right? So here b dash p, what we getting here? B dash p is what? V, and bp we are getting u, right? So from previous relation here we have from the two triangles here. So this can be written as the triangles. So from triangles ABP and A dash B dash P, right? So from that we can write B dash A dash by BA, that is equals to B dash P by BP. So by using this relation, so B dash A dash gives the height of the image, that can be written as HI. So this one is the HI, and here this one is AB is height of the object HO. BA is taken as HO, right? So next B dash P is the what we have here, that is minus B, right? Minus B. whole divided by BP, we have minus U. So now BA is what here? B dash A dash. Here we are measuring the distance that is below the principal axis. So that means the height of the image we are going to take as minus. So the magnification M is equals to height of the image to the height of the object. So here minus minus get cancels. So here we are getting HI by HO is equals to minus B divided by U. Right? So magnification M can be written as M is equals to minus B by U. So this one they ask for 1 marks. Write the magnification in terms of image distance and object distance. Right? So in the next class we will continue the topic refraction. Thank you.